Today we're going to figure out if lines are parallel, perpendicular, or neither. And we're going to do that simply by given what points determine the lines. So when we compare slopes, we're only looking to see if they're parallel, perpendicular, or neither. In other words, how they related to each other. So first thing we're going to look at is parallel. And this, you don't have to write this down. This is something we've already talked about. But remember, two lines are parallel if they go in the same direction and they don't touch each other. So what I'm going to do is I'm going to graph three different slopes. I'm going to graph two different slopes. Well, two different lines that have the same slope. So first one I'm going to graph is, let's do up 3 over 1, and you can start wherever you want. So I'll just start at this point over here. I'm going to go up 3, okay, and then I'm going to go over 1. So that gives me this new point. And just a rough sketch here. I'm not very good at drawing, but it's going to be something like this. Okay, so that's up 3 over 1. So that has a slope of 3 over 1. All right, now I'm going to start at a different point. I will start just randomly right here. And I'm also going to go up 3 over 1. 1, 2, 3. So there's up 3. And I'm going to go over 1. Now, when I graph this line, I can see that it's not exactly perfect, but basically you get the point. They are parallel. They go in the same direction. They just don't touch each other. It's like train tracks. All right. So this one also has a slope of 3 over 1. And if they have the same slope, it looks like they're parallel. Let's do a -1. I'm going to go down 2, start at a random point up here. I'm going to go down 2 and over 3. Okay, so that would have a slope of -2 over 3. And the line's going to be something like, that's not good, let's try this again. Something like this. Okay, so that's down 2 over 3. Now I'm going to start at a different point. We'll start right here. Again, doesn't really matter. I'm going to go down 2 over 3. Okay, and if I sketch that line, I can see that those are going to be parallel. Okay, so in general, we don't need to do a third one. Two lines with the same slope are parallel. That's definitely something you need to write down. You can just write same slope dash parallel. And if two lines are horizontal, which means their slope's 0, obviously they're going to be parallel. Two vertical lines would also be parallel. Two lines that have an undefined or infinite slope. Does anybody remember the definition of perpendicular? Yep, they cross each other at a 90-degree angle. We've already copied this down, so you don't have to do it again. This is just a refresher. But what I'm going to do with slope is I'm going to show you what that looks like. So can somebody raise their hand and just give me a slope? Not too complicated, kind of simple. Anybody? I keep picking these. All right, fine, I'll pick this one then. I'm going to do 2/3. And I'm going to start at a random point, so let's just start here. I'm going to go up 2 and over 3. Okay, so this line has a slope of 2/3. And it's going to look about like this. Not perfect, but basically. Okay, now the way that perpendicular lines work is you take this fraction and you flip it and then you make it negative. So the next line I'm going to graph is -3 over 2. You flip the fraction and you make it negative. Okay, so again, it doesn't actually matter where you graph the second one, but I'll just start, let's start up here. So I'm going to go down 3, 1, 2, 3, and then over 2. All right. It's hard to connect these dots sometimes. Okay. So see if I can, whoops. See if I can move this up this way. Nope, I can't move it. All right, we'll just rewrite it up here. So this line has a slope of -3 over 2. And if you notice, they formed a 90-degree angle. Okay? That's always going to happen when you take the slope and flip it and make it negative. Okay? You can see exactly how they relate to each other. One is flipped and negative from the other one. Certainly you could start with -3 over 2 and flip it and make it positive, and you'd end up with the purple line. But anyways, that's how perpendicular slopes work. So two lines with the negative reciprocal slopes are perpendicular. I know it's kind of complicated, but the word reciprocal just means the fraction's flipped, and then it's the opposite sign, negative. So if you start with a negative slope and you wanted to find what's perpendicular, you would flip the fraction and make it positive. You would do the reverse. The way this would look algebraically is if you started with line 1 and it had a slope of a over b, the perpendicular line would just be negative b over a. Pretty simple. Or you could say b over negative a. It doesn't really matter, again, where the negative goes. In that particular case, lines 1 and 2 are perpendicular. So we're going to take what we learned yesterday about just finding the slope of two lines and the points, and we're going to figure out if they're parallel, perpendicular, or neither. So, first example. This one's actually really easy. So I started out with an easy one. It already gives you the slope. It says line 1 has a slope of -4, and line 2 has a slope of 1/4. Are the lines parallel, perpendicular, or neither? Who wants to answer this one? Okay, so how did you figure out they were perpendicular? All right, so let's write -4 as a fraction, and you'll be able to see this. -4 as a fraction is -4 over 1. Now, if we compare, so this is line 1 and this is line 2. If we compare those two, we can see that if you flip this one and make it positive, then it becomes this one. So they're negative reciprocals of each other, so they're perpendicular. This is the easiest type of question where they already give you the slope. Okay? But let's do one where we actually have to find the slope. Of course. Line A has points -3, 4, and 5, 7. So we're given one set of points. Line B has points 5, -2, and -2, 0. So all of these questions today are asking, are they parallel, perpendicular, or neither? And the way we're going to solve this is we have to figure out their slopes first and then just compare them. So step 1 is going to be to find the first slope. So we're applying yesterday's lesson to today's lesson by doing that. Of course, to find the slope, I always recommend writing out the formula. And we'll write M1 or MA, meaning the slope of line A, be y2 minus y1 over x2 minus x1. As always, you need to label these points. So this would be x1, y1, x2, y2. Then I'm just going to plug them into the formula. So y2 is 7, y1 is 4, all divided by 5 minus -3.
Really confusing because the y looks like a 1 over 2.
Yes, it does. All right, so for the first slope, we're going to get 3 on the top and 8 on the bottom. So that's the slope of line A. I'm just going to put M sub A. The second step is to find the second slope. Okay, I've already written the formula. I'm not going to rewrite it, but I will make sure and label this. This is x1, y1, x2, y2. Okay, so the slope of line B is going to be 0 minus negative 2 on the top. And negative 2 minus 5 on the bottom. So the top, 0 minus negative 2 is a positive 2. And negative 2 minus 5 is a negative 7 on the bottom. So looking at this, guys, yeah, so slope 1 is 3/8, slope 2 is 2 over negative 7. Pretty much, if they look that much differently, in other words, they don't look opposite reciprocals and they're not the same, we can answer and say neither. They are neither perpendicular or parallel. Okay, you only got 3 choices for today. Turn around. Perpendicular, parallel, or neither. Two more examples. Again, you only have to write the steps out once. You guys understand. I mean, you find the first slope, you find the second, and you compare. Make sure you write those down. All right, I'm going to go ahead and label my points here. First slope. Again, every time I'm just going to write this formula out. And I wrote it wrong that time. M equals y2 minus y1. Or x2 minus x1. Okay, so for line 1, it's going to be 5 minus negative 3 on the top. Again, notice I'm putting everything in parentheses. And then negative 4 minus 4 on the bottom. Okay. So what's 5 minus negative 3? Good, 8. And negative 4 minus 4, negative 8. And what does that simplify to? Negative 1, okay? So I'll figure out the slope of my first line. It's negative 1. On to the next one. This is x1, y1, x2, y2. Okay. So we're going to have negative 5 minus 6 on the top for the slope 2. And negative 3 minus 8 on the bottom. Negative 5 minus 6 is negative 11. And negative 3 minus 8 is also negative 11. So slope 2 is what? 1. So slope 1 is negative 1 and slope 2 is positive 1. What do you guys think? Perpendicular. If you don't see that, you could write each of these as a fraction. This would be negative 1 over 1, and this would be positive 1 over 1. And certainly if you were to flip this and make it negative, it would become this one. Okay? Now it wouldn't work if it was 5 and negative 5. Those would not be perpendicular, because if you flip 5, it becomes 1/5. And then if you make it negative, it'd be negative 1/5. So just, it only works with 1, because if you flip 1, it's the same thing, right? So the answer for this one is perpendicular. I'll just write, you can just shorten it to PERP, it doesn't matter. Okay, one more example, I promise is the last one, and then I'll let you guys work on this. This is x1, y1, x2, y2. All right, so slope 1 would be 3 minus negative 2 over negative 1 minus negative 8. Okay, so that simplifies to 5 over, anybody know what negative 1 minus negative 8 is? Mm-hmm. It would be negative 1 plus 8, which is 7. Okay. Negative 1 minus positive 8 would be negative 9. Okay, so line 2, we have x1, y1, x2, y2. Okay, so we got negative 4 minus 1 on the top. And Negative 1 minus 6 on the bottom. Negative 4 minus 1 is negative 5 on the top. Negative 1 minus 6 is negative 7 on the bottom. What does that simplify to? 5 over 7. How do line 1 and line 2 relate to each other then? Parallel. Yep. It actually could be the same line. That's a good point. If they had the same, like, yeah, points, like if the points were the same. The points don't have to be the same. I guess technically, even if they are the same line, they're still parallel. So the answer for this one is parallel.